In this presentation, I'll be explaining different collectors used in solar thermal system. Therefore, to collect the solar radiation and convert into the thermal energy, what are the different collectors used that one? That will be explaining in this presentation. Now coming to the solar thermal collectors, solar collector is a device for collecting the solar radiation and transfer the energy to a fluid that's called heat transfer fluid that is passing and in contact with this one. For the solar radiation, for example, this is a one type of called flat type collector. In this one, solar radiation is falling here and that is converted into heat energy by this collector as such, and that is being transferred by using a fluid. Here we are using a pumping a fluid, that is this heat transfer fluid is coming here, and here to get a hot water, the cold water is coming to here to this setup as such heat exchanging mechanism. Therefore that is getting heated due to this temperature of this heat transfer fluid, and that hot water is coming out of that one. Similarly, this can be used for to come to a boiler also. Therefore, in this case, the solar radiation is converted into thermal energy by using this collector that is called a flat type of collectors. Now, the two types of collectors, solar collectors, is that one we call it as non-concentrating, or that's called flat type collector. The second one we call it as concentrating type or focusing type of collector. Therefore, these are broad classification of collectors, non-concentrating and concentrating type of solar collectors. Now continuing the classification of solar collectors can be classified broadly as non-concentrating and concentrating type. So this is called concentrating types, that's called flat type of collectors. This is a flat type collector. And in concentrating type itself, there are one we call it as focusing type, and this is called the focus type of, and this is called the non-focus type of collectors. This is a focus type itself. There are two types. One is called line focus and point focus. This is the focus type of collectors, and this is called the non-focus type of collectors. And non-focus type of collectors, there are modified flat type collectors, compound parabolic type, concentrating, CPC type of collector. So there are different types of non-concentrating type of collectors and focus type of collectors, non-focus type of collectors. This is called concentrating, or that's called the non-focus type. And focusing type means line focus, that is on axis tracking, it is focusing on an axis, and that is a cylindrical parabolic concentrator and fixed mirror solar concentrator and linear Fresnel lens collector. Therefore, there are three sort of classification. And point focus collector, that is two axis tracking is possible here. That is paraboloidal dish collector, hemispherical ball mirror, concentrator, and circular Fresnel lens concentrator, central tower receiver. Therefore, these are the types of point type focusing collector, and this is a line type of focusing a collector. Both are focusing type of collectors, and this is a non-focusing type of collectors. All these are coming under the concentrating type. Another one is called the non-concentrating type of collector. Therefore, the focus type collectors, that is, these are all focus type of collectors. In the focus type of collectors here, this is one. These are called focus type of collectors. In the focus type of collectors make use of beam radiation only. Here only beam radiation. But non-focus type of collectors make use of both beam radiation and diffuse radiation. Both beam and diffuse radiations are used to convert the solar radiation into heat energy. That is non-focus type. But in focus type, that uses only the beam radiation. Therefore, solar collectors, non-concentrating type, concentrating type. In concentrating type itself, focus type and non-focus type. And that these are the different types of non-focus type. And in focus type here, line focus as well as point focus type of collectors. Now let us see the important features of solar collectors. What are the parameters or specification as such? Collector efficiency. Collector efficiency means the ratio of the energy actually absorbed or collected and transferred to the heat transport fluid by the collector to the energy incident on the collector. That ratio we call it as collector efficiency, collecting efficiency, that one, collector efficiency. Second one we call it as concentration ratio, CR, the ratio of the area of aperture of the system to the area of the receiver. That is called the CR, concentration ratio. The third one is called the temperature range. The range of the temperature to which the heat transport fluid is heated up by the collector. How much temperature range is there? That's called the temperature range. Therefore, these are the three things: collector efficiency, CR, concentration ratio, and temperature range. These are the three specifications of the solar collectors. Now, for example, here, flat type of collector. This is a flat type of collector. In flat type of collectors, the temperature is less than 100 degrees centigrade is possible by that one, and the CR equal to 1 as such. If it is a line focus, is that we can increase the concentration ratio into up to 100, and the temperature range can be increased to 150 degrees centigrade to 300 degrees centigrade. That is possible by this line focus. Now, if it is a point focus, that again the temperature now increasing by point focus, that's around 500 degrees centigrade to 1000 degrees centigrade is possible by point focus collectors, and CR is also much higher, that is 1000. Therefore, these are different types of collectors, like flat type collectors, line focus collectors, point focus collectors, and these are the different ranges of the values of concentration ratio as well as temperature range. Now let us see the first one, flat type collectors. It's a non-concentrating type of collector. The main components of the flat type collectors, that is the flat type collector, it is shown here. The main one is that transport cover, which may be one or more sheet of glass or radiation transmitting plastic film or sheet. Or radiation transmitting plastic film or sheet may be the either glass or transmitting plastic film may be that. That is here, the top here. That is the transport cover to transport this solar radiation into this one. The second one is the tube fins passage or channels to carry the water or air and other fluid, heat transfer fluid. That is this one. Second one is the tubes or that carries the heat transfer fluid, the second component as such. Next one is the absorber plate. This is the absorber plate as such. This is the absorber plate. The absorber plate is normally metallic or a black surface that absorbs the radiation and converts into heat energy. Therefore, this is the tube as such. This is the absorber, and this is the transport cover as such, top glass type of cover as that. The fourth one is this is the insulating medium. Therefore, the insulation at the back and side to minimize the heat loss. To minimize the heat loss, there's an insulation is provided here. Therefore, standard insulating materials like fiberglass can also be used for this one. Therefore, this is the insulating medium as such. These are the tube through which the heat transfer fluid is passing, and this is the absorber plate that absorbs the solar radiation and converts into heat energy. And here, this is the top cover as such. Therefore, this is the flat type of collector, picture as such, and casing for the protections. These are the casing, there should be protection also there. Therefore, this is the basic components of the flat type or non-concentrating type of collector. Therefore, this is a pictorial representation of a heat, solar heater as such, and therefore that absorbs both beams and heat radiation. Therefore, this is a non-concentrating type of that one that absorbs both beam and diffuse radiation, and no sun tracking system is used in this type of non-concentrating type of, or that's called flat plate collectors, to collect the solar radiation and convert into thermal energy. Now, continuing the flat plate collectors here, the solar radiation strikes on a special treated metallic absorber. That is absorber is this one, metallic absorber, and heat is transferred to the heat transfer fluid which is circulating in the tube. That is it. After absorbing, that is transferred to the fluid that is flowing through this tube. And the thermal insulator is used to prevent the heat loss from the rear surface of the collector. There's a thermal insulator is provided. And glass cover permits the entry of the solar radiation. This cover enters the solar radiation as it is transparent for the short wavelength and opaque to the longer infrared radiation reflected from the absorber that is absorbing here. And thus, heat remains trapped in the airspace. That heat may remain trapped in the airspace between the absorber plate and the glass cover. here absorber plate, this absorber plate, and between this one, the heated air is being trapped, and that heat energy is transferred to this heat transfer fluid by this mechanism. Therefore, the heat remains trapped in the airspace between the absorber plate and the glass cover here, that is being trapped here, and similar to the greenhouse effect that is happening here. Therefore, that thermal energy is being transmitted, or that's transferred to the fluid that is passing through this one. Therefore, that is called flat plate collector. Now, continuing the flat plate collector, flat plate solar collectors may be divided into two main classifications based on the type of the heat transfer fluid. That is, liquid heating collectors are used for heating the water and non-freezing aqueous solutions, and occasionally for non-aqueous heat transfer fluids. And that is, heat transfer fluid is passing through that one. Second type is that air or gas heating collectors are employed for as solar air heaters. Air or gas are being transmitted. Therefore, this is a liquid one, and this is passing through the gas is being passed. Therefore, anyway, the heat being transmitted by this either liquid type of collectors or liquid type of passing through that one, or air or gas type of is also used. Therefore, that is the flat type collectors. The advantages of flat type collectors, they have the advantage of using both beam and diffuse radiation can be utilized here. Both radiations, beam as well as diffuse radiation. They do not require orientation towards the sun. They requires little maintenance. This type of flat type collectors requires little maintenance, and they are mechanically simpler than concentrating type of collectors or absorbing surface and orientation device of focusing collectors. Therefore, it is mechanically simpler compared to other type of concentrating type of collectors. Second one we call that concentrating collectors. Concentrating collectors. In concentrating collectors, concentrating collectors are used. Collectors use mirrored surfaces to concentrate the sun's energy on an absorber called a receiver. For here, say this is the mirrored surface, the sun and the energy of the sunlight, or that is falling on this one, that is reflecting to a center point here, like this one. Here, through that one, heat transfer fluid is flowing through this one, that gets heated. Therefore, this is the receiver, and here the solar radiation is falling on that one, that is concentrating, that is focusing on an area here. Through that one, the fluid is flowing, that gets heated because of this. Therefore, the concentrating collectors also achieve high temperature when direct sunlight is available. Some designs concentrate solar energy onto a focal point, that is the focal point of here, and while others concentrate sun rays along a thin line called focal line also there. There are two types of that one, we will see later that one. Rather than to a point, through a line it will be concentrating. Therefore, the receiver is located at the focal point or along the focal axis. That depends. If it is a point wise, it is at the focal point, and if it is along the line, it is a focal line, it will be concentrated. Therefore, the heat transfer fluid flows through the receiver and absorbs. Therefore, the heat transfer fluid is flowing through this one, that absorbs the heat energy, which is focusing on this one. Therefore, that is a concentrating type of collector. This type of collector we are using. Continuing the concentrating collectors, and here as we have seen similar to that one, that is concentrating here, solar energy concentrating here, and that can be even tilted also. This one, the schematic of concentrating type of collector that can be tilted to the solar radiation. The mechanism is also there. However, the concentrators can only focus on the direct solar radiation, with the result being that their performance is poor on hazy or cloudy days. Concentration perform best when pointed directly at the sun. To do this one, these systems are used by, to do this, these systems use tracking mechanism like this one. A tracking mechanism is used to move the collectors during the day to keep them focused on the sun. So a tracking mechanism is provided so that it can track the sun always by doing this tracking mechanism, and that can concentrate on a focus point like this one. Therefore, trackers need frequent maintenance. That's the one disadvantage, is that there should be trackers can be used, and the disadvantage is that there will be frequent maintenance is required for these trackers. Therefore, this is a concentrating type of collector. The types of concentrating collectors, they are classified as parabolic trough collectors, mirror strip reflectors, Fresnel lens collector, flat plate collector with adjustable mirrors, compound parabolic concentrators. There are different classification of the concentrate type of collectors as such. Coming to the parabolic trough collectors, the parabolic trough are devices that are shaped like the letter U. This one, it's a parabolic type of letter U, and the troughs concentrates the sunlight onto a receiver tube that is positioned along the focal line of the trough. For along the focal line, this is a line, it's a line focusing. Therefore, here this is the collector and the solar energy is focused on along this line. Therefore, sometimes a transparent fluid tube envelopes the receiver tube to reduce the heat loss. Therefore, transparent glass tube envelopes the receiver tube to reduce the heat loss. For their shape are like a U as shown in the figure. This is the parabolic trough collectors picture, and this is showing a parabolic trough system as a number of parabolic type of trough collectors are kept here like this one. Therefore, this is a cross section of parabolic trough collector. This one. Continuing the parabolic trough reflectors here. Parabolic trough reflectors have been made of highly polished aluminum silver glass. This one, silver glass, or of a thin film of aluminized plastic or on a firm base. Therefore, that is parabolic trough reflector. For the solar radiation to be brought to a focus by a parabolic trough reflector, the sun must be in such a direction that it lies on the plane passing through the focal line and the vertex. This one. And trough type of collectors are generally oriented in east-west or a northeast, north-south directions. Therefore, this is a pictorial representation of a parabolic trough reflector that collects the solar energy and that will be made to focus on this line. For a number of collectors can be, this type of parabolic trough collector can be connected, and each one there will be focusing through this each lines, and finally you can combine that one as a parallel like this one's mechanism. Therefore, that's called parabolic trough reflector. This shows a typical cylindrical parabolic system as such, as we have already seen. Parabolic type of collector is the number of times can be connected in parallel as such. Here the heat transfer fluid can be passed to that one. The heat energy will be focusing on this line so that that gets heated. And similarly, this is another picture of the parabolic type of collector. And this is another type. This is a pictorial representation of a typical cylindrical parabolic system. Another type of collector is called mirror strip reflector type. Therefore, in another kind of focusing collector, number of plane or a slightly curved mirror, plane mirror or slightly curved mirror strips are mounted on a flat base like this one. In a flat base, number of mirrors are mounted like that one. The angle of these individual mirrors are such that they reflect the solar radiation from the specific directions onto a same focal line. Here the mirrors are connected like this one, and here the solar radiations are reflecting towards the focal line, same focal line it is reflected. And the angle of the mirrors must be adjusted to allow for a change in the sun's elevation while the focal line remains in a fixed position. Focal line remains in a fixed position, but as the sun rise or sun position is changing, that mirror angle of mirrors should be changed that one. Therefore, that is another one is called mirror strip reflection. Mirrors are kept, and that is that solar radiations are focused to a line. Therefore, that is mirror strip reflection type of collector. Next type of collector is called Fresnel lens collector. Fresnel lens collector. That is made up of acrylic plastic sheet. This is an acrylic plastic sheet, flat on one side. This side it is flat, and with fine grooves on the other side. Here the grooves are there, and this side grooves are there. Here it is flat also. The angle of the grooves are designed to bring the radiation to a line focus. This angle of these grooves are designed in such a way that this line solar radiation that focus into a focal point and to a focus, that is that in a line focus, that is through this line that focus it heat radiation. Therefore, that is by providing a grooves like that one. Therefore, the angle of these grooves are designed to bring the radiation to a line focus. Therefore, that is called Fresnel lens collector. That solar radiation is made to focus that one in order to convert into thermal energy. The next one is called central receiver collector. Solar radiation is reflected from the field of heliostats to a centrally located receiver on the tower. The tower, centrally located receiver, and heliostat is a device that continuously tilts a mirror or a multiple mirror faces to track the sun's movement to reflect the sunlight towards a predetermined target. There are, that can be rotated, that mirrors can be rotated, and that can be focused into a point on this one. To a predetermined target, it can focus that one. Therefore, a tower collects the light concentrated by the heliostat. Therefore, like this one, it collects, that is, it can be collected at this point. Just a pictorial representation shown here. And heliostat onto a central receiver on the top of the tower. On the top of the tower, there's a central receiver right there. Through that one, the solar radiation is falling into a central receiver on the top of the tower. Tower height ranges from approximately 300 to 650 feet. This height is that. The heat transfer fluid composed of either water or a molten nitrite salt moves through the receiver, and it is heated to a temperature of 500 degrees centigrade. The heat transfer fluid is passing through that one, that is getting heated because of the concentrating that one on the top of the tower. Therefore, this heated heat transfer fluid is then sent to a heat exchanger where the water is turned into a steam, which then drives the turbine generator. Therefore, that is a central receiver collector, and the receiver is located at the top of the tower. At the top of the tower, this receiver is there, and it has got a high CR ratio. Concentration ratio is around 3000. And a large field mirrors called heliostats tracks the sun. That is called heliostat. It's a lot of mirrors are that is concentrating the radiation in the top of the tower. That is called heliostats, and this type of mechanism of collecting is called central receiver collector. Continuing the central receive collector mechanism, as I already explained here, there are mirrors are there that can be tilted and that can be concentrated on the top of the tower. There's a top of the tower, it can be concentrated, and the fluid is flowing through that one, that gets heated, and that is mechanism how that heated energy that's going through a heat exchanger, and that heat exchanger that is converting into steam, that is going to a turbine, and that is coupled with a generator, and electrical power can be generated like that one. That's a pictorial representation of that one. Say central receiver collector system, how the solar radiation, thermal energy of the solar radiation can be converted into, of course, finally it was converted into electricity. For the tower with a central receiver at the top, that is the central receiver at the top, is that heat conversion subsystem is the, and heat storage device and field oriented mirrors are there. Therefore, these are the components of the central receiver collector system as such, that one. Next one, we call it as compound parabolic concentrator, CPC, compound parabolic concentrator. CPC is a non-focusing, but solar radiation from many directions is reflected towards the bottom of the trough as such. Therefore, this is a pictorial representation of a CPC, that is compound parabolic concentrator. Provides moderately good concentration, although less than the focusing type of collectors, in an east-west direction without adjustment for the sun tracking. That is shown here as such. The compound parabolic concentrators can accepting incoming radiation over a relatively wide range of angle. Incoming radiation or a wide range of angle it can receive it by using multiple internal reflection. That is, here we are using a multiple internal reflection. Any radiation entering the aperture within the collector acceptance angle, within the collector acceptance angle, finds its way to the absorbed surface located at the bottom of the collector. Here a absorbing surface, a black surface is there, that will be absorbing that one. And here this is the axis of parabolic A, and this is a parabolic A, of course, the parabolic A, and of course this is a parabolic B as such, and heat radiations can be, sunlight radiation can be this aperture as that one, that through that one that can be radiated, and that gets heated at the top. This is called compound parabolic concentrator. Advantages of a compound parabolic concentrator: there is no need for tracking as it has high acceptance angle. Acceptance angle is much higher. Therefore, no tracking is required. Only essential adjustments are required. The efficiency for accepting diffuse solar radiation is much larger than conventional concentrators. Its concentration ratio is equal to the maximum value possible for a given acceptance angle. The maximum concentration ratios available with the parabolic system is the order of 10,000. Therefore, the CR ratio is much higher here, and this is the compound parabolic concentrator. Finally, that solar energy is concentrated on this one, on this, that get heated. Now let us see what are the advantages of concentrating type of collectors over flat type collectors. This is a flat type collector and this is called a concentrating type of collectors. And reflecting surface required less maintenance and are structurally simpler than flat type collectors. For a concentration type system, the cost per unit area of solar collecting surface is therefore potentially less than the flat type of collectors. The absorber area of the concentration system is smaller than that of the flat type system for the same solar energy collection, and therefore the isolation intensity is greater. Concentrating systems can be used for electric power generation when not used for heating or cooling. The total useful operating time per year can be therefore be large for a concentrating type system than for a flat type collector. And the initial installation cost of the system can be regained by saving the energy in a shorter period of time. Therefore, these are the advantages of concentrating type of collectors over flat type collector. This is a flat type collector and this is a concentrating type of collectors. Therefore, there are a lot of advantages for the concentrating type over flat type collector. If you look into the disadvantages of this concentrating type of collectors over flat type collectors here, out of the beam and diffuse solar radiation components, only beam components is collected in case of focusing type of collectors because diffuse components cannot be reflected. Now, other one is the additional requirement of maintenance, particular to retain the quality of reflecting surface against dirt, weather, oxidation that is required in the case of concentrating type of collectors. Non-uniform flux on the absorber where the flux flat type collector is uniform, that is solar radiation, no, that flux solar flux is that is uniform in the case of a flat type collector, but is not uniform on the absorber of the concentrating type of collectors. Additional optical losses such as reflectness loss and the intercept loss, therefore losses are much higher in this case of more than this, and losses in this one concentrating type is much more compared to the flat type collectors, and initial cost is higher in the case of concentrating type of collectors. Therefore, these are the disadvantages of concentrating type of collectors over flat type collectors. Therefore, this is a flat type collector and this is a concentrating type of collector.